Hello, and welcome to the Red Hat 2022 Summit virtual event. We're so excited that you could join us for this session today. My name is James Walton, and I'm an Associate Principal Cloud Solution Architect with Red Hat. And I'm joined today by Joshua Dietzick, a Principal Cloud Engineer from Cigna, and Chris Porter, Director of Solution Architecture for Advanced Cluster Security at Red Hat. As our session title implies, we're here to discuss today how Cigna was able to rapidly enhance their security posture for OpenShift using their GitOps practices and Red Hat's advanced cluster security for Kubernetes. With security being a priority for many enterprises today, the ability to effectively manage application and platform security while also able to respond with agility to changing security issues and environments is very critical. Ultimately, the goal is to be able to enact, manage, and monitor security policies from a single source of truth, and then ensure that you can distribute and maintain those policies across your environment wherever they apply. So before we get into the how of Cigna applying their security policies in OpenShift, we want to learn a little bit more about the why. So Josh, can you walk us through and tell us about your OpenShift environment? Like, how large is it?
Thanks, James. Yeah, so as you can see on this slide, the size of our OpenShift environment is pretty significant, and we expect growth of upwards 100% over the next year as we continue to move additional workloads off of some of our legacy platforms and onto OpenShift. Some high-level stats on our size. We currently have 725 nodes between our production and non-production clusters. These nodes combined consist of over 23,000 cores of compute power and 124,000 gigabytes of available memory. We're currently one of the largest OpenShift customers in the world. A common question we get from our security team is what kind of images are in our environment that have unmitigated vulnerabilities present in them. For the past few years, our answer has always been to look in the image registry and leverage the data provided by the built-in CLAIRE security scanner. We even built a homegrown tool that we call Endorser that development teams utilize in their deployment pipelines. Endorser's job was to query Quay and CLAIRE and validate that an image that was attempting to be deployed was compliant with a set of rules, which included the absence of critical and high-severity vulnerabilities. An image would only be signed by Endorser if it passed these compliance checks. The signature it supplied is necessary for the image to run on the cluster. The combination of data from CLAIRE and enforcement from Endorser worked for quite a while. But as our OpenShift clusters grew from tens of nodes to hundreds of nodes, and application deployments to the platform grew exponentially, deficiencies in this method of tracking and enforcement quickly began to surface. Applications that were once being actively deployed weekly and in some cases daily eventually moved into more of a maintenance mode as application development teams moved on to newer projects and priorities. With the lack of active development comes an inherent exposure to new vulnerabilities discovered after an application has been deployed to production. We were quickly finding that applications that had gone to production months and even years back had dozens of new vulnerabilities being discovered in the image. But without development teams actively deploying, these issues were not always being remediated in a timely fashion. Some of the questions we found ourselves and our information security partners asking were, how do we detect new vulnerabilities post-deployment? How do we know if an image that's been flagged with new vulnerabilities is currently deployed, and if so, where is it deployed? How do we ensure developers follow best practices and required information protection standards? And lastly, how do we detect anomalies in an application's network activity? We evaluated multiple tools and solutions with varying levels of success in their coverage of the gaps we identified in our current workflow. For us, the clear answer came from our trusted partners at Red Hat and the recent acquisition of a security tool formerly called StackRox, which is now rebranded as Red Hat Advanced Cluster Security. I'm going to pass off now to Chris, who will give a brief overview of what ACS is and how it works to solve these problems.
Great. Thanks, Josh. Advanced Cluster Security is a new name for StackRox, but the same mission. This is software for security teams that is designed to help organizations that are making this transformation into DevOps to layer in security in that process. We see that organizations are adopting this DevOps model with a pipeline-based build approach. And it has significant advantages for business agility, being able to quickly adapt to changing business requirements. We think that that same transformation is going to benefit security as well. And that security that's in line with the tools, the platforms here, and the processes that Cigna's adopting have a great advantage for security teams as well. So we call this, of course, shift left or DevSecOps. We call it cloud native. But the idea here is to address common security use cases in a software product that can be used in a pipeline that is native to OpenShift and the Kubernetes API. Those 6 use cases cover vulnerability management, probably the most foundational control. This is identifying where those images come from, where they're in use today, what components they have, and what kind of vulnerabilities impact the components that are part of that, and providing that information to developers so they can fix it. We also cover configuration management, which is a basket of settings that include how applications are using the services in an OpenShift cluster, like network exposure or the use of storage or secrets or privileges for service accounts, because a lot of these configurations do have security implications. The next use case is what we call risk profiling. It's a holistic view of applications and how things like vulnerabilities, privilege levels, network exposure interact with each other to increase the likelihood that an attack occurs, or that if an attack is successful, how likely is it that an attacker will be able to use a compromised container as a way of furthering their attacks in the environment by establishing a foothold, maintaining a backdoor into the environment, or moving laterally to attack other applications running in the cluster. Speaking of which, the fourth approach to security that we're using here is network segmentation. The idea of limiting an attacker, preventing the disclosure of data or the exfiltration of data out of the environment by restricting the kinds of network access that a given deployment has. This is container firewalling. The solution here is designed to use the controls that are native to Kubernetes. And network segmentation, leveraging Kubernetes network policies, allows us to accomplish those goals of containing an attacker wherever they might land, and also help us meet compliance standards, which often require isolation of sensitive data. Compliance is the next major security use case. It covers industry and regulatory compliance and how the stance of an application meets those requirements laid out by some of those common standards. We also finally talk about runtime protection. We know that solving vulnerabilities, minimizing access and exposure can all help to prevent an attack, but you have to remain vigilant for running workloads in an OpenShift cluster because attackers may still gain a foothold. And we have to examine the network and container process activity to identify when that activity might actually be related to a threat actor working in the environment to get to achieve their goals. On the next slide, the architecture of the product is, as I mentioned, a software product. It is based on the original StackRox software product, and it's roughly a client-server architecture. And this is going to come into later points in the slides about how to deploy this. There's a single central control plane, what we call central, where there's a single UI, the so-called single pane of glass, as well as a single policy engine that allows us to build and roll out policy consistently across these environments. So when the security team decides on a policy around managing the risk of vulnerabilities, that's consistent across all of the environments. Each cluster in a large environment like this will have the secured cluster services running on them. Everything here is built as Kubernetes deployments, daemon sets, horizontal pod autoscalers. It's easy to automate, and it is built in a declarative way that you'd expect of a Kubernetes native product. A lot of what we're going to end up talking about here is third-party systems, because integrations with existing security tooling, integrations with existing developer tooling like CI/CD pipelines and image registries is a critical way for this product to function. And so those integrations are performed at central, done in an API-based approach so that it can be, again, automated and consistently configured.
Thank you. That was a great cover of really how Red Hat Advanced Cluster Security functions and where the value comes from. Now, Josh, you and I have been working together with Cigna systems and how you guys have been using Red Hat technology for a number of years now. And, you mentioned that you guys came to the decision of using Red Hat's Advanced Cluster Security, or ACS. And the initial plan that we had talked about was doing a very gradual rollout, taking that phase at a time as you integrate this new technology into your environment, which is, your typical use case of methodical way of going about. But there was a shift in how you were going to approach that this year. Can you tell us more about what that motivation was to kind of accelerate your usual timeline?
Yeah, thanks, James. So I think, like many companies in the world, and I'm sure many of you listening now, we were in December, winding down towards the end of the year, in what's usually a quiet time for us. And we were shocked out of our complacency of December to learn about the discovery and publication of the critical Log4j exploit. So this usually quiet time of year was instantly interrupted by dozens of emergency meetings with various stakeholders across the company, from developers to executives. Everyone was pretty much asking the same question. And that question being, what's the exposure that we have to this, and how do we mitigate it as quickly as possible to not put any risk to the business? As you can imagine, the complexities of not only determining which images are vulnerable, but where they're deployed, which clusters, with clusters of our size, is not an easy task. Fortunately for us, we just acquired licenses for Red Hat ACS, and with some of the sophisticated automation and cluster management we have in place, utilizing Argo CD GitOps, we knew we could engineer a quick and easy solution to roll out ACS at scale to all of our clusters. The ACS operator exposes two main APIs for configuring and deploying the product. As you can see in this image, we chose to break up our ACS deployment into two separate Argo applications, each representing a Helm chart that we created to deploy that specific set of components. Breaking the resources up in this way allows us to use Helm templating and cluster-specific value files to target which clusters would host an ACS central instance and which central each secured cluster instance should report back into. On this side, you can see a screenshot from the Argo console showing the 5 main resources that make up the central Helm chart. The main resource is the StackRox Central Services custom resource, which the operator uses to tell it how to configure the central, scanner, and database components. The other resources are a certificate for use by the ACS console and a service account and role binding to be used by the job we've defined. We chose to use jobs to configure Central because currently the only post configuration that Central allows for is through its own API. Using jobs allows us to still define the configuration as code in Git and have Argo run it for us in a job pod. The job will configure everything from console authentication to third-party integrations, email server configurations, enforcement and alerting policies, and so much more. The next slide shows a screenshot of the secured cluster resources defined in the secured cluster Helm chart. This chart is responsible for deploying the secured cluster custom resource, which the operator uses to deploy sensor, the collector daemon set, and the admission controller. Aside from the custom resource, you can see, once again, the service account and role binding used by the job to enroll and configure the current cluster against the specific ACS central mapped in the Helm chart's values. Lastly, this slide shows the enrollment job from the previous slide. To comply with our self-imposed mandates of automating everything through GitOps and infrastructure as code, we wrote a simple script to take otherwise manual tasks of requesting an API key from Central and generating the required init config to register the cluster and automate them. We started with a basic image that included the OpenShift CLI. At runtime, we download the ACS rockctl command line tool from the pre-mapped Central instance. This is to ensure we are always getting the correct version of the command line utility that corresponds with the current Central version we're running. Next, we use curl to make an API call to Central to request a cluster-specific API key. We use a predefined username and password that we configured with Central in the Central custom resource. Once we have the API key, we then run the generate init build command provided by rocksctl, which returns a package of YAML secrets for this specific cluster. Finally, we run an OC apply against those YAML files that we got back to create the secret resources. The cluster now has all the secrets required by the ACS sensor pod to reach back to Central and begin transmitting data from that cluster. I'm sure this all sounds simple, and at the end of the day, it kind of is. That isn't to say, of course, that we didn't encounter any challenges along the way. I'm now going to pass it back off to Chris to talk about some of those challenges and how we overcame them as a team.
Thanks, Josh. Yeah, we've been working together for almost 2 years now on this, and on our side, we certainly learned a lot and been able to deliver some additional features and, of course, to fix issues that we've run into during the deployment there. That real-world experience has been helpful for our product management and engineering. And by our, I mean the StackRox prior to acquisition, as well as after we joined Red Hat here. Some of the things that we were working on at the time of our initial engagement was to integrate with some of the tools that you're using for security event management. And that's tools like Splunk and IBM's QRadar. And we've since published and released our integration settings for those, as well as documentation on setting that up. We know that this product typically goes into environments that have established processes for handling security events, and we want this product to fit in with those existing tools. Of course, we didn't go completely here trouble-free. We did have some challenges. We ran into conflict with some of the OpenShift SCCs. This was a mistake on our part that we were able to correct. And I know that you asked some additional flexibility in being able to deploy this in non-standard namespaces. And we've made other changes to this operator as customers have provided us with feedback about how they want to use the tool and to deploy it. As we've been working, of course, the scale at Cigna has given us some challenges, and we ended up identifying and fixing some issues that we saw with the Quay integration. We weren't handling connections correctly that caused an overload on the Quay side of things. We were able to get to the root cause and resolve that. And while we were doing that, our engineering team was able to identify the correct scoping support for Quay tokens. So this is this kind of thing that takes work in a real environment to surface these issues, and really do appreciate that you've worked with us so long to identify the problem, help us reproduce it, and then to verify that the fixes that we provided have been able to resolve the issues that you have. We also know that the scale here has certainly created some interesting challenges. We've seen memory usage go up in the product here, caused by ultimately the number of unique images. Tracking all those vulnerabilities and all the images across all of those nodes isn't free. We try to make good use of the resources available on the cluster. And we actually have some improvements coming up to how this memory gets used and reclaimed, so that we're not forced to continually add memory to the product as the cluster environments get larger. Some of the other things that we talked about early on were quickly resolved. After the acquisition by Red Hat, we delivered a number of OpenShift-related authentication and integration features. One of the things that we wanted to avoid was having users sign in separately to that management dashboard versus the tools that they're already signing into. And so we delivered those features. With your help, we've got more coming. Product feedback is what makes this product, and experience with our customers is what has made it as successful as it has been. So thank you.
Thanks, Chris. So I thought, as a kind of closing discussion that we could have, it would really be great to learn a little bit more from you, Josh. What are some of those key things that you learned from, and what is the value that Cigna's really gotten out of this, initial deployment of ACS?
Yeah, sure, James. So I think some of the most important things that we've learned is first of all, scale. It really complicates things. A lot of time QA testing happens in a bubble against predefined, kind of simple environments, and clusters and scale of our size bring a whole new level of complexity. The sheer number of pods that we're running in our environment, and the number of images that they're attached to, really changes the game for the number of resources that are being monitored. Also, understanding vulnerability exposure at runtime is just as important, if not more so, than build. I think for a long time, we were under the impression that the data that we were getting back from Claire was sufficient, but we quickly realized, as I kind of said before, that it really isn't enough to know what's in your registry, because your registry is often not representative of what is actually being deployed in the cluster. You may have a dozen images in a particular repo, but only one of them is actually deployed. And which one of them is it? Is it the most recent one that has no vulnerabilities, or is it the one 3 series back, which has several high vulnerabilities attached to it? Second, the value from the solution for Cigna. Now we're able to alert on vulnerable deployments and notify development teams for remediation. We identify configuration issues earlier in the development lifecycle using RockCTL coupled with Teams pipelines. They get feedback earlier on before they even deploy to a cluster if anything in their image that they're choosing to build or the actual spec they're deploying goes against any of the policies we've set within ACS. Lastly, we can detect network and execution anomalies from running containers. This has been helpful if we find that teams are logging into containers and executing commands in what should otherwise be an immutable image.
Thanks. Yeah, that's really great to hear. And I really think that this has been a great opportunity for Cigna and Red Hat to really continue building that partnership that we've had for a number of years now. Whether it be through the consulting services that we have assisting you guys with this ACS work that we're doing. And even more so, the fact that because you are such an advanced user and someone who's willing to, adopt these technologies early in their life cycle, we establish those direct lines of communications between you guys who are working with the product out, in the field essentially, and getting you to be able to talk to people like, Chris here and his team of engineers and solution architects, which has been really valuable for you, especially as they continue to work on things, going forward. And Chris, can you touch on, some of those things that are coming up?
Yeah, there's a lot of exciting things on the roadmap here for ACS. You're going to see additional integrations and automation capabilities. One of the things that Josh and I have talked about is enhancing the GitOps nature of ACS, policy as code, and that is definitely a goal that we want to drive towards. You're going to see some additional security innovation in the platform. Right? It is a security tool. The threat landscape is always changing. There's new focus on things like secure supply chain, and you're going to see features from ACS this year that will deliver on some of the developments in that space. The last thing, of course, and what probably have a lot of our audience as a question is, where's the open source project for ACS? Well, the StackRox name and logo is going to be preserved there as the upstream project. And by the time you're watching this, it should be released. As of the recording here, it's not quite done. We're not ready to release it for open source. You can follow along with the community at StackRox.io, but we expect that it'll be available very soon.
Thanks, Chris. And thanks, Josh. Really, it has been a great discussion we've had today, just talking about the success Cigna's had and the efforts that you guys are doing to improve the security posture, for your enterprise. And really, from the three of us to everyone out there watching, we just want to thank you for joining our discussion today about fast tracking DevSecOps using GitOps and Red Hat's ACS. And remember, Red Hat Summit 2022 virtual event will remain accessible online until the end of the year. Thank you and have a great day.